So we're hoping you enjoy that. And let's welcome John Considine from IBM.
Thank you, sir. Thank you. All right. Well, welcome. CloudEXPO, the 21st. You didn't think clouds were around that long. I think it seems that we run CloudEXPOs on the East Coast and over in Europe and all, and the numbers increase. Hey, look, so over the next 3 days, I wanted to welcome you to the CloudEXPO. Over the next 3 days, there are, I think, an amazing set of discussions going on here around microservices from my friend Andrew there, artificial intelligence, serverless computing, CI/CD, DevOps. Good thing to pay attention to, GDPR, right? Compliance, what you're going to do about data privacy and all of that. I know a lot of folks like us in the cloud are working hard on issues around that concept. Multi-cloud, all of that, something that we're real big into. And so look, I'm John Considine. I'm the general manager of IBM's cloud infrastructure. I run all of the global networks, all of our data centers. We build and operate our data centers, and then build and operate our infrastructure and infrastructure as a service. So this is everything from bare metal to virtual servers, network storage, all of the building blocks of cloud. IBM, although you might not hear it in the press, is a global scale cloud provider. And so for the next 45 minutes, I'm going to go through detailed product data sheets and offerings from IBM and sell hard to you. No, I'm not going to do that at all. What I'm going to do instead is I'm going to talk about the evolution of cloud. I think by looking back at what we've done over the last about 10 years, would be insightful in terms of what we thought at the time, how it's actually played out, and then some of the things that are really driving us hard in the cloud, in the cloud provider space, to talk about how I think it's going to go and some of the big trends and some of the pressures on the cloud. So here's what we're going to do. I'm going to take a look back. We're going to walk over kind of what happened over the last few years. We're going to talk about some of the key cloud attributes. Should be obvious, but I like to hit them because they show some of the trends about what's happening here. Then I'm going to do a word on costs. I love to see the different things happening in the ecosystem and in the press and everything about talking about cloud and what it costs. And then we'll take a look at some of the things that are driving us forward and a look forward, okay? The only other thing I would say about what I'm going to talk about today, and Roger hit it a little bit, we, particularly IBM, are very focused on the enterprise. And you say, why is that? And you'll kind of see some of the things threaded through my slides here talking about the enterprise. Here's a really simple answer to that with respect to cloud. Enterprise is where all the money is. Okay? Now that doesn't mean that we ignore developers and startups and all of those other things, but when you think about the global economy, the global IT spend is somewhere in the order of $3 trillion a year. Okay? So if you look at our global scale cloud providers and what we're doing, the solutions, the innovation, the drive, the expansion of capabilities, it really is how to solve the problems for the enterprise because that's where all the money is. Okay. Now I need my clicker. So I have very exciting slides you can see here. They're mostly black, but let's go a look back. Roger mentioned that. I had a startup in 2008. In 2009, we came and presented here at the CloudEXPO. And I was on a whole bunch of different panels, and we did a lot of presentations about the cloud. And the fascinating thing about that, right, this is a little less than 10 years ago, the big debate was cloud real? Was it just a fad? Are people branding it different? Is it going to make a difference? Well, of course, now we sit here in 2017 and go, yeah, I think the cloud might be real. But let's think about what was happening in those early days. Really, if you think about the start of the cloud, as we know it, the public cloud now, we think about Amazon and the first introduction of cloud. There were a few things before that, though, that are kind of interesting, right? We had a lot of things going on in the cloud space, or the precursor of cloud, I'll say. I worked at Sun Microsystems from about 2002 to 2007, and we did what we called utility computing, right? So we're stringing together a lot of computers, and we're making them available so you could buy them by the hour. Of course, what was missing, right, in those models is there were two things we were doing. We were doing it for HPC. We We were, high performance computing, and we were doing it for batch processing. You could run all these computers and run them really in this kind of parallel fashion. And it was, well, interesting. It was a potential business. But what was missing is the models, the access models, the business models around there. And so really when we look at the cusp and what really changed for cloud computing, again, 2007, 2008, it was the idea that you could get these resources to consume your things, easy, fast, and away you go. But probably equally important, and really about the ripeness of events, right? And we'll talk about this later today, but about how things were evolving at the time. So think about this, right? If you go back 2007, 2008, we were kind of in the crazy mania of web services, right? Mobile first, starting to really come down on the idea of what is DevOps and all of those things. Those things were all happening about the same time and creating feedback loops in the ecosystem, in the technology, and what was happening. And so really all of those things coming together in and about this time is what changed the cloud computing, what actually enabled the cloud computing. So the model changes that we're talking about here aren't just about the technology, although that's pretty important, right, about the how we build and how we deliver the services, but it was also, about changing the development process, as I say, web apps and all of these things. So the other piece that we think about as cloud computing came to life was really about access to resources. So now let's kind of split the world again. Thinking about enterprises and getting resources. And I don't know, a lot of you guys have been involved in enterprise sales. I've worked on enterprise products for a lot of years prior to the cloud coming to age. And the idea of getting resources, what do I say resources? Getting a server to run your application inside, I don't know, I'll say a bank, inside a retailer, inside, pharma, inside one of these things, you'd be talking 3 months, 4 months, 6 months to get the server and the storage you need. Well, it creates a lot of interesting problems, right? Because if a resource is so hard to get, then you hoard them, you over-provision, you say, well, why don't I get like 10 of them, even though I need 2 of them, so I don't have to wait next time. When you get storage, we used to laugh about this, where a developer or a product group would say, wow, I need, remember, these are big numbers at the time, I need 1 gigabyte of storage, right? And then the manager would go, well, let's make it 10 because we can't wait for it to come. And then the IT guys, well, geez, they want 10. We should probably give them 100 so we don't get pinched. And the guy that ordering it was like, well, I'm going to make it 500 instead of 100. That way I don't have to make another order. And suddenly you bought 500 gigabytes of storage for 1 gigabyte usage. So the models were kind of stretched out and causing a lot of interesting problems. But if you think about what happened then with the cloud and these access to the resource, it was anyone. Right? So a developer, a group, a team could access resources and suddenly they could get them set up and run. Somewhat connected, or at least connected to the internet, which is an interesting challenge in the early days, but they could get the resources they want quick. Now that enables this wave of evolution. People can try, and you guys know now it's pretty standard procedure, but fast fail, the idea of getting something, trying it, and if it goes, great. If it doesn't, throw it away, go on, try something else. But think about the challenge of this, right? This whole changing culture on IT. It's one of my favorite things to say about IT. The mindset, the goal, the rule for IT, you ready for this? Is don't change anything. Change is risk. Risk means I get hurt, right? Because, I take down the corporate email server, I take down the financial records, I take down something, I lose my job, the company's hurt, everything else. How do we know this happened? Still happens to some extent today. Well, they batch up changes. You do 1 change a year, 2 changes a year, right? In terms of patching up the systems and doing all those things. Wow, that's pretty crazy, right? And only then because either something was out of date or there was a security patch or something like that. So IT's whole mantra, all of the idle process, all of the governance, all of the process was to effectively freeze and stop change. Okay, so now this cloud thing comes along. We quick. We want to be fast. Look at how easy it is. Look at what people are doing out there. Fantastic. Now look at what the change or the pressure on our IT guy. Now we want you, Mr. IT guy, to help us be agile. Okay? We want you to help us be the center of innovation, to get the resources to make things happen. Now look at these poor guys. One side, don't change anything. The other side, change everything as fast as you can. Okay, so now you wonder why cloud adoption enterprise has been slow. That's part of the big reason, right? There's a conflict in terms of how we even think about it. All right, so that's some backdrop. Now, the arguments early years, 2008, 2009, even 2010, is cloud real? Is it going to go? Is it not? And there was kind of two big camps out there. It's going to change everything. I think Roger talked about this. It's going to change everything right away, or it's going to take 25 years to change everything. Well, the interesting part is the cloud grows. Here's the one thing we know for sure. The cloud grows, right? Every day it gets bigger, bigger by a lot. Why is that? And I will tell you, I believe fundamentally it's a better model. Okay, so we're going to talk about a little, some of the problems in the back, but if you have a better model, if you have a better way of doing things, by definition it grows. It really is the footprint of a classic disruptor, and that's what we have with cloud. All right, now a couple more thoughts in terms of a look back. The early clouds were strange, right? I don't know how many of you guys coming from a classic background, IT and services and product development and delivery and all of those other things. But when we started working with clouds like Amazon in the early days, they had crazy notions like ephemeral storage. Ready for that? I mean, is that one of the dumbest words you've ever heard? It's my storage, right? And how do you always think of storage? It's where I keep things because I want to read them later. But the way they introduced this is if that machine were to crash or you were to turn it off, all your storage would be gone. What the heck is that, right? Why would you have that? Now, of course, it evolves, right? Things get better. There are constructs and networking. There's things about, things on the public internet and addresses assigned, all these other things that made it hard to do the things that we've traditionally done with our infrastructure. And the trade-off was you get this fast and easy and this simple environment to go. So look, the evolution of the cloud, very simple. Start with these things that were stateless, right? Look, I'm making a web service. It's a front end. It gets its data from somewhere else. I'm not going to say somewhere else. It loads up the front things. You can do your transactions. You can do your web service. You can, put your data up and interact with it. And then scale it. Add more, because I got a lot of people using it. Or shut it down, shut it down, shut it down. Let me tell you, it's very easy to use the cloud in a stateless fashion if you can use it in a stateless fashion. But then time clicks on, all right? So you think about what we're seeing in the evolution. So we go from this crazy ephemeral storage notion to, persistent storage. Nice evolution. But then geo-expansion, databases, right? Think about this, right? We're stepping up the complexity level, the utility level for enterprises. Then guess what? Go after security. I'm going to talk a little later about security, but go after compliance, go after all these things. And so here's the trick. The cloud itself, the entire ecosystem and capability is under a continuous improvement cycle, okay? It's part of competition, part of serving the market. It's getting better and better. So we're seeing more sophistication, more applications, more services, and it's a faster and faster loop. All right. Attributes. All right. Quick talk about some of the attributes. Now look, this becomes hard. This used to be easy to talk about the attributes of clouds because they were pretty simple. Now they do an amazing amount of things. When you look across the total landscape between the private and the hybrid and the public and the multi-vendors on public, there's a lot of attributes. But I pulled out a few that are interesting to take a look at. So one of the first one is global availability. This has become a big part of cloud computing. You got to remember, in the early days, it was, believe it or not, a US phenomenon. It was even a relatively localized US phenomenon. But remember, if you have a better model, the consumption goes up, right? People want more. They need to do more. And so now you have an interesting set of strategies around global availability. Because what do people want? They want to be able to have the same service, the same capability, but there's a whole list of reasons why you need to geographically disperse. Some of the easy ones: your users, your customers, your partners, your remote offices, or whatever else want to be near wherever you're doing your computing. That's a customer experience, right? Fast response times, it's where it is, it's part of the community, everything's good. That was the early days. That was kind of a big push. Increasingly, this kind of a distribution is for data sovereignty. It is for protection and keeping the data within regions, within countries, within states in some cases. And the idea here is there are laws in place that are restricting the access, the storage, and the deployment of data. And so now, if you want to provide these services, and you need this area, you want to provide it to the EU, right? The European Union, you have to have the data and the systems in the EU, or people can't do it. Okay? And so now you get to this geographic model. Now you've seen even recently announcements for different cloud providers. By the way, these are my data centers. I have roughly 60 of them around the world. I've built about 8 or 10 so far this year. I have 8 or 10 more in the process of being built. What does this tell you? Cloud computing is growing. Consumption's going up. We continue to push on this geo dispersion, right? To make this resources available wherever you need them or want them. So the thing then to think about the cloud and this distribution is that the cloud becomes effectively a channel. So now let's come back. Let's come off of our enterprises. Let's talk about innovation. Let's talk about startups, about people building new services and capabilities. The beauty of the cloud model, you make it up there in Toronto, right? You use the cloud service to build some cool new thing, and you can now deploy it worldwide. People can access it locally from virtually anywhere. Pretty powerful model, and it's another thing that's giving cloud a great boost because you have that capability. And of course, I would be remiss if I didn't talk about cloud security. Look, back in the day, you like that? Back in the day, when I was a little kid. All right. Security was probably considered the #1 inhibitor for cloud computing. Some goodness there, probably some FUD, right? Fear, uncertainty, doubt. And I would say mostly the uncertainty part, okay? So we spent a lot of time, and increasingly so, by the way, this isn't something that's going away, worrying about security, about penetration, about loss of data, about all forms of hacking and everything else. And the idea that there is a cloud provider out there where all my stuff is a problem, right? Because it's not me, it's someone else. Now here's why I say it's a funny thing about uncertainty. Shared responsibility is the model, okay? Now it's funny because really everyone has a broad spectrum of shared responsibility in their everyday business anyway, okay? It could be from, where your buildings are and access control. It could be, who's administering the databases. I mean, there's all sorts of things around what happens for responsibility, right? But the cloud says you are going to now work with a company to deal with the, and again, we'll call it risks. So let's come back. There's a fun one. This is a model we talked about a few years, and I think General Electric worked out this kind of a model. And they said, look, about 5 to 10% of our infrastructure is old stuff, okay? It's stuff we don't want to touch. Very complex, very ugly. Might be mainframes. Look, the guy from IBM said mainframe. All right, and what we want to do is kind of push that stuff into the corner and leave it alone. It's too hard, too difficult. And then you get about 5 to 10% of your stuff, IT, infrastructure, capabilities, that are the crown jewels. The things that you couldn't fathom getting out there into the world, unrestricted. And we used to, talk about GE and those folks. This would be like their jet engine designs, right? Their future technologies, what they're doing, all of those things. And they're generally easy to find because you get into a company and you say, oh, look, there's a restricted hallway and no one's allowed to go down there. Whatever's at the end of that hallway, they're not going to put in the cloud. Cool, right? But that's not the big part of your business. If you add those first two categories together, 80–90% of what you do is important but undifferentiated. Great idea for putting into the cloud, but now you say, what do I have to do about security? So what am I talking about here then? It's a fascinating one, and folks in the industry have really spent a lot of time looking at this. If you go to a financial institution, right, they have to be careful, right? They have to protect the data. There's all sorts of regulation, audits and compliance, all sorts of things piled on. And so they build very strong systems and very tight data centers, and things are locked to machines and networks. As a joke, back in 2008, I was trying to sell one of the big banks on cloud computing, and I made some software that let them use the clouds. And the guy pulled me aside and he goes, wow, this is really great stuff, but I got to tell you, we're a bank, and it was only last year that we allowed VLANs to be used in our networking instead of separate network switches and architecture. I went, thank you. I'll call on you in a few years, let's say, to talk about these things. So they're very strict, very things. And then there's a little bit of, I don't want to call it laziness, but I will call it this, risk aversion again. So that all applications, all data, everything gets treated the same way, because then you don't make a mistake. And so now you have these big systems, all of this work for compliance, everything else, and now you say, it doesn't matter if it's a fund screener that's using public data, or you're publishing your prospectuses or whatever else that aren't actually protected or shouldn't be or don't need to be, but I'm going to put them in those same systems because it's easy. So this is this notion about data classification and type of workloads. The idea that for any company, all of their workloads are equally important, equally from a security, from a client's perspective, or compliance perspective, crazy. Why would you ever do that? Because it's forcing you to be the most strict, the most complex, the most costly, when the reality is the whole bunch of work you do is, what did I say before, very important, but undifferentiated. So the trick then with this, shared responsibility then comes to hybridization. What I say before, there's stuff that you're going to leave behind because you don't want to mess with. There is stuff that is your crown jewels and will never go anywhere. And then there's everything else. So this leads to the notion of hybrid cloud computing, right? Blending the workloads, what you do in your own data centers, what you do in co-location facilities, what you do with different cloud providers, because they either have different locations, different compliance, whatever else. You now have to work out what it means to be in a hybrid model. Now we have a kind of a fun one. Inside IBM, we talk about this whole process of, let's say, hybrid cloud computing is a very simple way. Public is the destination. It is a winning model, and hybrid is how you get there. Now, that also seems to imply that hybrid is transient, but I would tell you from some of the case I just made, I don't think it's transient. I think that you see more and more grow, so the growth comes up in the public cloud, but you always will have this hybridization. And it's not just from your own data center to the cloud. It could be from your data center to another data center, to a cloud, to multiple clouds. So the notion of hybrid is how do you blend the environment to get your work done? Okay, so let's go back and say one more thing then, and this is my personal foible on here, is that people talk about security and they keep talking about security. I hate calling it cloud security, although I put a slide up that says it. Here's why. Security could mean anything to anyone at any time. And what you really have to get to as you walk through all of this is risk management, right? So you identify the risks. And just one quick funny story on that. Back to trying to sell to the banks early, 2008, 2009, cloud. And I was explaining, we encrypt all the networks and we encrypt the data at rest and the encrypts the data in transit and we use your keys and everything. And CIO goes, He goes, you think I'm worried about that? He goes, my number one risk is the database administrator with a password to the main database. Right? He's like, I couldn't care about the encryption of the stuff in the back end. There's somebody who could go move all the money, delete all the transactions, poof, right? I'm good. So the trick with cloud security, and everyone's learning, right? And there's things, I mean, we do, back to IBM, not selling. We do all this work around risk management, compliance, all these things, because it's the end-to-end solution that ultimately becomes very important on here. And so it is risk management, identifying what the priorities are and then going after them. The model of the cloud, still pretty superior here. All right, enterprises. I talked before, this is where all the money is, okay? So let's think about the evolution, what's happening in the enterprises. The enterprises, it's kind of a joke, are fast followers in the cloud space. When I say fast, I mean slow followers in the, in the cloud space. But look, the glomming onto getting into the whole cloud space. So we look at this as kind of 3 waves of cloud computing. And it starts with, we call efficient infrastructure. This was the original draw, the value prop, the vision for cloud is, man, cheap resources out there somewhere. And don't worry, I'm going to talk about cost in the next slide or two, but, and that was a motivation. But really, that's only a little part of the motivation. I mean, it was a way of get going, dev test. People were thinking now that, instead of taking 6 months to get a server, to get the stuff to build and run my applications, now I could get it, you ready for this? In a virtualized world, I could get it in like 3 days. It's like, oh my God, what's wrong with you, right? We're thinking cloud, I can get it in 3 minutes, right? So the idea with efficient infrastructure was kind of a lift and shift, dev test. The idea of same thing we follow with virtualization, that at some point, my lower critical things I could just do. It's a nice environment, I get them done, and when I get back to being serious, then I run it back in my enterprise. Not a bad model, interesting one, but things have evolved a bit. We talk about application modernization. I spend a lot of time with businesses, with customers, with a lot of different folks on application modernization. So the value prop shifts from this idea of you're going to get cheap resources to we need to get into a real DevOps model, to get really to continuous integration, to continuous deployment for what we're doing. And then we want to take the apps, and I love this, modernize them, right? Build them in current architectures. Get away from some of the heavy and complex old architectures. Take advantage of some of the cool things happening in space. So this is the idea of building new apps to say, we used to do it this way, we're going to do it this way. We call it application modernization. We do a ton of work in this space today in the cloud because, again, it's a great medium for people to really get involved and go. Now, the cool thing about working on application modernization, if you remember, I'm the general manager of IBM's cloud infrastructure, is that as we do work for application modernization, it drives workloads into the infrastructure. Thumbs up, I love it, where we go. All right. So then what's really evolving, okay? How do we go? This process reinvention is also a really big part. And we'll say, like you get the little, Watson thing going there. This is the idea of, bringing in artificial intelligence, deep learning, machine learning, data analytics, all of these things to your process or to your business to say, how can I do even more? How can I enrich the experience? How can I add new capabilities? How can I do more, right? I mean, just across the board. And again, as soon as we start talking about process reinvention, then you do drives application modernization, drives infrastructure, and this is really an engine that really drives more and more consumption and utilization of the cloud, which is why I love it. All right. So let's talk about cloud solutions. This is the big deal, okay? So the way I generally talk about this is, we draw this great big picture here. And my business is kind of the lowest boxes on there, my personal business, okay? It's the little stuff on the bottom. And it's great, right? I mean, it's cool, it's growing like mad, doing all the data centers, doing all the build out, all the capability. But where is all of the value? What are we trying to get done? And here's the trick. It's about solutions. Because as we think about getting business done, about just improving, almost any dimension of what we do today, it is about the solutions. And so when you think about the cloud then, you have kind of 2 axes in which you can go after the cloud. You can enter from any level that you're interested in. So look, I love them. They come to me and they go, oh, I want virtual machines, or I want bare metal servers. I'm going to set up my network. And there's folks that are going to configure firewalls or firewall rules and all of that. Thumbs up. But then we get people that come in and say, well, I don't care. Whatever happens down there, I want to deploy containers. Or I want to do CF push. I want to use Cloud Foundry. I'm going to build my app, and somebody or something is going to make it run. You can come in at data, right? So you come in and you say, well, I'm a data scientist, and I have these data sets, and I'd like to combine them. I'd like to pull out information. And I don't even care about containers and all of those things. I actually want to run analytics. I want to do things. Or people coming all the way to the top. Man, what I'd really like to be able to do is build a new model against this stuff, and I want to use some other framework, and I'm going to push a button. It's going to eat the data. It's going to create all these things in the bottom. It's going to make me a solution. So one axis is letting people enter and utilize the cloud however they're prepared to. But the other axis, very important, is the solutions, the applications coming down, and what I call it is a vertical slice through the stack, okay? So when we think about, logistics, right? Having solutions that go end-to-end, they don't care how many VMs are on the bottom or what the firewall configurations are. They actually have, solutions. They were actually trying to get their business done. And so when we think about the cloud and the evolution of cloud, you see that we get stronger and stronger in the componentries. If you look at the cloud, public cloud providers, they're kind of working up the stack, adding more capabilities, more features, more functions. It's thumbs up, it's awesome, right? These are composable services. Instead of me having to build all of this crazy stuff, I can call it, I can use it. But they're still composable. So think about that. That means you have to know what all the pieces are and then how to glue them together and all of that. So what you're seeing is an evolution of the frameworks, of the templates, right? Things Terraform and all these other things where you can describe your stuff in a bigger level, and then it goes ahead and processes things beneath you. Now, it even gets bigger, right? Because you say, oh, well, we have solutions for data. Life scientists, we have life sciences, we have things for IoT. We have whole solutions where now it's drag and drop this thing as part of my application, my overall application. Pretty powerful about what's happening in here. Okay, so the only other thing I want to say here is, and you're gonna love this one. Back to my earlier discussion about ephemeral storage and that being an oxymoron. Data turns out to be perhaps the most important thing, okay? Because when you start thinking about all of this other stuff, right? All of the frameworks, all of the infrastructure, my computers and my networking and all of that stuff, they're necessary. Well, they're very important. I'll probably show you in a few slides kind of what's happening in that space. But when it comes down to it, the data is the thing. So we believe, and I believe it's pretty broad out there, that data is one of the enterprise's most important assets. And so handling of data, how do you get it? How do you ingest it, enrich it, make it available? This is a big center, okay? Now, by the way, IBM, I'm talking about for cloud in general, everyone kind of gets this. This is a huge important aspect of, everything, right? Business across the board. So data first, look more about how this is being handled and manipulated, how it's delivered. And again, think back why there's data centers all over the world. Now the data can be part of that data sovereignty locality. And now all of the services either support it in terms of how do you get it and manipulate it, or they consume it to transform it into high value capabilities. But again, solutions are the key and the future. Oh, yeah, I tell you, Hari, I hate this slide, but you see what's happening here, okay? So there's a continuum here, right? And I'll talk about a little bit about what's happening. But you talk about workload portability. This becomes an interesting topic over this notion of lift and shift, or when I develop it once and I use it many times. I think there's enough old people in this room like me that remember Java, write it once, run it everywhere. Sure, it's all great. But this is a version of that, except cloud proper, okay? So when you get to virtualization, VMs, we think things like VMware and just virtual machines in general, maybe AMIs from Amazon, VSIs from us. if you look at what's evolving here, containers, and I have to tell you internally, we're going crazy on containers, right? Containerizing our applications. Just another form of virtualization, but very lightweight, and it really facilitates increased portability of workloads. So think of that in 2 dimensions, right? That's scaling, deployment, the development and test and runtimes, moving from on-prem into the cloud or to dedicated, moving between clouds. Containers are giving a little more of a, I call it a slip surface, or make it easy to move things around. But it's not ending with containers. Go forward. We think about functions, right? Functions. Serverless functions, serverless computing. Again, this is the idea of, having the idea and not necessarily the implementation is part of how you build and develop your applications, your solutions, and your process in here. I'll probably do one quick thing on serverless computing. I know that there's a whole bunch coming up. I think there's some sections during CloudEXPO on it. I had a funny one. Somebody came to me the other day and said, oh man, serverless computing is going to kill you cloud providers, right? Because everyone's not going to run VMs. They're just going to have these little event-driven things, and now your utilization is going to go way down. And I laughed. Here's the thing. We love serverless computing, right? It is an efficiency for everyone, right? Instead of everyone building their listeners and having their VMs and then doing all their logic, that they can use it as a service, okay? Here's the trick on serverless computing and the events. Event-based computing is very cool, but again, you need databases, you need to process things, you need all sorts of things that either record or interact or do more than just purely event-driven. Now, there's some cool people who do everything in there, but what we really find it is, as we do more sophisticated things, it drives more consumption. And again, for me, cloud provider, love it. Okay. This is one of my favorite ones. The cloud is cheap. The cloud is expensive. Who here thinks the cloud is cheap? Come on. All right. And who thinks it's expensive? Okay, who has no thought at all? Okay. Okay. I love this. By the way, one of my startups, I went and I was trying to get funding. It was CloudSwitch, the one we came out here with. And I was trying to get funding for an idea that we're going to help enterprises use cloud computing in 2008, which needs to say I'm a big optimist that way, right? I think if you could show somebody it's better, it's faster, it's cheaper, they would have to adopt it. Well, I learned the hard way. But what I found there was, and we do the due diligence and the whole thing, that we got 2 answers back. And this is at the time. Amazon is super easy to use and cheap. Amazon is really complicated and really expensive. And I will tell you, for all those budding entrepreneurs out there, if you ever get an answer like that from the population, there's an opportunity. I can't tell you what the opportunity is, but there is one. All right, so let's think about this. Cloud is cheap. You guys hear, you hear these stories. I read them out there. Amazon is 3.8 times more expensive than doing it myself. You get stories out there that big storage providers and all these other things are moving off of Amazon into their own data centers because Amazon's way too expensive. Well, there's 2 problems kind of threaded through here. The first one is, of course, how you count things. I've seen a lot of these things, and I do this with a lot of businesses too. Well, I can buy a disk drive, a 4 terabyte disk drive for $157. And if I have 4 terabytes of S3, it's going to be $400 a month. I don't know, whatever the logic is. Well, so here's the trick, right? A disk drive, great. What about all the software that lets you, store things? Well, then you can't have just one because the disk drive will fail, so I need some. And then it's upgrades, it's patching, it's operation, it's power, it's cooling, it's the guy that knows how to fix it. And I guarantee you, and it's happened to anyone, including me, that runs object storage or runs storage at scale, someday you're going to come in and all the data is going to be gone. Okay? You're going to go, oh my God. Now you're going to spend, things are good, minutes, things are not so good, hours. If things are really bad, days or months to recover the data and go through all of this stuff. I guarantee if you store at any volume that this will happen to you. So now, does paying the extra money make sense? Maybe, right? The idea that your data might be irrevocably lost. Pretty tough stuff. The other one is, in terms of the cloud being expensive, is how you count it. Well, I have the people anyway. I already have the data center space, so erase all of that. And I'm going to take the cost of a server and I'm going to divide by 3, 4, 5 years. And man, look how expensive cloud is. All right, fine. That's one side. We can go back and forth on how we count the beans. But there's maybe another one that's much more important here about the cloud being cheap, the cloud being expensive. Here's the trick. There is no doubt that if you want to take a single application and optimize your infrastructure around it, you can cut corners, you can make it cheap, you can actually make it work. But think about what you're actually doing, right? You're locking yourself into an architecture, you're locking yourself into a solution, and that as things come along, serverless computing is going to come along, AI, all of these other things are going to come along. You're now not part of that ecosystem, you're in your own world. But equally important, imagine that you spend all of your time optimizing the infrastructure and the low-level components to get your application done. Well, what you're not spending time on is the uniqueness of your application. You are doing cost optimization, which could be valuable, but at the expense of spending time and effort and money at I'll call it the more important things that you do. Now, the last piece I'll say on this, though, is unless you decide you're going to try to build a cloud and compete with us, compete with Microsoft, compete with AWS, to build a cloud, to really build a cloud, and I say good luck because you're not going to be more efficient than us in any way that you can think of. All right. So, let me just give you a real example. This is great. We bought, I don't know if you guys know, but IBM bought the weather company maybe almost 2 years ago. And they had a great thing about moving from, they own the stack and the data centers and everything else, to pure cloud. This is a big transition. We model after this. We spent a lot of time on this. But look at what happens. They had 13 data centers that they were maxing out capacity on. They're doing planning and all of those other things. But they needed 60 to 70% of their investment in their quote-unquote technology people just for maintenance and operations, okay? And by the way, you say 2.2 million data points computed and served every, 4 times per hour after, okay? So this is a 2-year period to do this transition. 2.2 billion points processed every, 15 times, every 4 minutes, okay? And their investment on the ops for maintenance and operations and all of that was shifted down to only 20% of their entire spend. So now they're taking their people and building cool applications, real value add, new capabilities instead of running their infrastructure. They're processing, I think, 1,000 times more data, and they're using far fewer people. This is a good scaling metric. Shows you that the costs are probably a little complex to calculate. Okay. So now I got 2 minutes to go step forward. All right. Look, I told you before, solutions. All right. Solutions, solutions, solutions. That's all you're going to hear me talking about in terms of how we think going forward. If you pay attention to all cloud providers, they are going towards solutions. Why? Well, again, that's where all the value is. That's what happens. Okay. The other bigger problem is, hopefully I won't offend anyone here, the enterprises need help. Okay. Shifting into these new models is not trivial. There might be new skill sets, there might be new people, there might even be new culture and attitudes about how you do things. And so solutions are really the way, doing the end-to-end. This is, everything from how you do maintenance and support and operations. Oh yeah, and how you build your solutions and the technologies you involve. There's a lot of pieces that come together, and I would say that as you look at cloud, what we're walking up the stack is providing more and more solutions. Now, this is done with ecosystems. This is done, individually. The idea of using, consultants or advisors, support mechanisms, all sorts of things. But solutions are where it's at. And of course, I'll be a little remiss if I didn't talk about AI. Okay, AI has a profound effect at what's happening today in the industry. I mean, the whole industry, right? Everything, but particularly focused on cloud. And part of the trick with the cloud and the capabilities here is that the cloud allows you to run very big, heavy, and complex things and still treat it as a service. And I'll give you some numbers in a moment. But the the impact on what we do here, and I'll give you some parting thoughts on that in just a moment. But let me give you an idea on the things. To build a single 300 megabyte model, okay? This is a deep learning model, 300 megabyte output, right? These days, no one thinks 300 megabytes is big. Using 200 million, 250 kilobyte images. So you can almost guess what we're doing here. Ready for the numbers? 300 million trillion math operations, okay? So those guys out there with the little calculators. If you were to do this on a single x86, it would probably take about 300 years, okay? If you did it on 1,000, you maybe, cut it down to be a year, a third of a year, a couple months. Well, if you do this with, I'll call it GPUs or advanced processors, you might even get it down to an hour or two, okay? Here's another one. To move the data to the GPUs to do this training, 60 gigabytes have to move to the GPUs on every iteration, every spin of the model, move 60 gigabytes, and then to come down to the interaction with storage, 2 petabytes have to move to and from storage as part of that process. So think about what that does to your infrastructure. Think about building that in your own data center. Whew, it's big, very expensive, very complex, but it puts pressure on the clouds. We're building solutions and capabilities to make this happen because this changes a lot of things. All right, so this is it, right? So machine learning, deep learning, natural language, content recognition. This is why I say it's changing everything. You can, and we like to call AI, you ready for this? Augmented intelligence, not artificial. And we say that because it's really about enhancing the workers and the people that are working in the space versus necessarily replacing them. Artificial intelligence, machine's going to take my job. This actually, when we look at it, it's about how to do things better, how to do things faster, how to be more efficient. It lets people do a lot more. And so when you look at what's happening in this space, I would say that we're looking at the enhancements of all of your applications and your solutions. And I try to draw a parallel here. If you think, go back a number of years, what happened when cell phones arrived, mobile devices. Do you remember the change in the industry about mobile first, about building applications, about your solutions to extend to those devices, to take advantage of that personal interaction, to expand and change all of that interaction with the users, the user base, right? The user experience. What I would say is happening in the AI space is directly equivalent, okay? We're talking about every application, every usage, everything. It's that same notion to fundamentally change what's happening, to extract the value and deliver new capabilities. And of course, through the cloud. Great, one just quick one, and I know I'm running just a minute or two over, but they haven't hooked me yet. All right, I'm a tech guy, so I want to show you this one about the evolution effects. And this is kind of cool, right? I'm going to come back to 2008, 2009 when we started this. The building of clouds, right, tended to be monolithic and hardware defined, meaning we took boxes from Cisco, we took boxes from the storage vendors, we took storage and we took compute, and we kind of put them together and built the infrastructure. What you see is we step forward, right? This is very rapid evolution, but we start to see convergence, right, between the storage and the compute and the network and all of these pieces. What we'd say today, and we build a lot of our infrastructure like this now, is really about a fabric interconnect. How do I put the resources on a fabric to disaggregate the physical functions so now I can boost utilization, I can boost efficiency, I can make things, well, better, faster, cheaper. Always winners. Now, if you think about where we are today, though, then it also continues to shift the evolution to be software-defined, and I'm going to say software-defined everything. It's a big deal, right? Because what happens for cloud providers in the integrated cloud environment is that having control of the software, building an integrated system, you're going to laugh, it's like I'm talking about a mainframe now, but building that integrated system actually lets you drive efficiency, provide higher performance, faster problem resolution, isolation, and then the introduction of new capabilities very fast. Now, what's next? What's coming? Things that we're working on, and we know people in the industry are working on, is creating resource pools in the cloud. So you think about this disaggregation. We take the disk drives out of the servers, and we kind of move the network functions into, well, go figure the network. think about this, disaggregating the CPUs and memories, disaggregating the devices, right? So think about our GPUs or our FPGAs or our capabilities. This disaggregation is very powerful to be able to combine those resources in new ways to deliver on an efficient infrastructure. It can be done only through the cloud because you have that vast pool of resources to then create this. And again, let me give you a simple one. The idea I can create a computer with a bunch of memory. If the memory isn't in a single computer, but is actually in a pool, then I can have different configurations, different scaling. Allows you to do some pretty amazing things. And then going forward, right, taking that same notion of fabric-based resource pools and all, and extending it across larger geographies. So there's implications on, kind of global networking and what we do in that space, even inter-cloud operation, how to actually blend these environments. So that's a really fast look at the future. All right, so look, cloud evolution, guys. 5 minutes over. Thank you, Roger, for not taking me off the stage. I want to say thank you and have a good time with the CloudEXPO. Thanks, guys. Thank you, sir.